Now, look at the problem of a profit maximizing firm that has revenue as a function of how much it sells, X given by P of X, where P denotes the price per unit of the good that it sells, and of course revenue is measured in dollars, and has costs as a function of X given by theta times X squared, again measured in dollars, where theta is a parameter that basically measures how costly is to produce the different units of the good. Now, question, what is the best that this profit maximizing firm can do? In other words, what level of X maximizes its profits? So we can set up the problem by writing it down, which says maximize what quantity X greater or equal than 0 maximizes profits as a function of X. This is equivalent to maximizing X greater or equal than 0. Profits are just revenues minus costs, so P times X minus theta X squared. Notice that this is the benefit function and that this is the cost function. Notice also that the benefit function has the following properties. B prima is going to be equal than P, so it's greater than 0. B double prima is equal to 0. C prima is equal to 2 theta X, and Z double prima is equal to 2 theta. Now, this is going to be greater than 0 for any X greater or equal than 0, and this is going to be greater than 0 as long as theta is greater than 0, which is a reasonable assumption, because if theta is equal to 0 or less than 0, it doesn't really cost anything to produce the goods. Now, what does this mean? It means that the concavity conditions are satisfied. Notice one more thing, which is that the marginal benefit at infinity is P, so it doesn't really go to 0, but the marginal cost at infinity is basically infinity. So it goes to infinity, which implies that the crossing conditions are satisfied. Now, why is this useful? Because now we know that we have a problem that falls in the case that we have developed. We know that there exists a unique solution, and that the solution has the property that is either 0 or solves marginal benefit equals marginal cost. Now let's take a look at this. We know that at 0, marginal benefit at 0, let me write it like this to keep the notation consistent. We know that marginal benefit at 0 is equal P, and that marginal cost at 0 is equal to 2 theta times 0 equals 0. So we know therefore that B prime of 0, since goods trade at positive prices, is greater than marginal cost at 0. And that implies that the solution X star must solve the marginal benefit of X equals the marginal cost of X. This is equal to P. This is equal to 2 theta X. And together, this implies, doing a little bit of algebra, that X star has to be equal to P divided by 2 theta. Now, one skill that is very important that you develop is to always check that the solutions make economic sense, that they are intuitive. And in this case, it kind of does. So think about it. What this probably is telling me that the firm will increase the level of output that it produces as P goes up. In fact, linearly with P. But as the marginal cost of production goes up, at that theta, this parameter that affects the marginal cost of production goes up, the level that it produces goes down. This kind of is intuitive, makes sense, and it's a good thing to check.